Hey everyone, in this video we are going to solve the three-sum closest problem in Leetcode. It is similar to the three-sum problem which we solved previously. The only difference is instead of checking if the sum is equal to 0, we have to check if the sum of those three numbers is closest to a target number. So we are given a nums array and a target, and we have to calculate the sum of any three numbers from this array whose sum when add together results closest to the target number, and we have to return that closest sum. So this is the question. Let's see how we can do it. So we'll use the same approach we used while solving the three sum problem. So we'll run first initially we'll sort this array. So after sorting this array will become -1, 1, 2, and 4. Now after this, we'll start a for loop from -1 all the way to the last element 4, and we'll also use two more pointers, left pointer and right pointer, and then we'll run a while loop. So, and that while loop will run while our left pointer is less than the right pointer. So if we try run this, so if we start from here, our for loop will start from here. So I will be here, start of the for loop. Then our left pointer will be this one just next to it, and the right pointer will be the end of the array, the last element of the array here. Now the difference between the previous threesome problem and this one is, instead of calculating that if adding these three number, so the three numbers we have are num set I plus num set L plus num set R. Adding three numbers in previous problem, threesome problem, we have to check if adding them results 0. But in this problem, we have to check the closest sum. And the thing about closest sum is, let's say if we have a target of 0 and we have two options, we have -1 and we have 2. In this case, -1 is the closest sum we could have got. So how do we get that? So to get that, we have to get the absolute difference. So absolute difference will mean irrespective of the sign, whether it is a negative number or positive number. So we have to check if the absolute difference of this one and the target, if it is less than some temporary variable which we'll be using, let's call it result, then we'll replace. So if this condition is true, then we'll replace the result with our this sum, and initially result will be the math dot max value, which is the maximum value a number can have in JavaScript. So initially it will be greater than, irrespective of what value we get, irrespective of the temporary sum we get here. So if we try run this, we'll start from here. So initially it will be -1 plus the value at left pointer, which is 1, and then the value at right pointer, which is 4. It will result 4, and 4 is less than our math.max value. So instead of math.max value, result will store now 4. Since the value we got 4 is greater than the target, will move the right pointer backward. So right pointer will come here. Now we'll again calculate the temporary sum. It will be -1 plus 1 plus 2, and it will be equals to 2, which is less than 4. So again our sum is less than result. So we'll replace result with our new temporary sum, which is 2. Now 2 is greater than target. So we'll move left pointer one step forward. But now our while loop will break because left pointer is now no longer less than the right pointer. So this condition, in this iteration, we have for in the first iteration of the for loop, we have find that the closest sum we got is 2. Now if we move forward, I will come here, and then n again, L will come here, and R will come here. Now you notice all these three are positive number. So adding them will always result a sum which is greater than 2. So there is no need to try run this solution, but if you want you can try it yourself. And so at the end our output will be this 2. The time complexity for this one will be same as the previous threesome problem, O of n square, and space complexity will also be same, O of n, since some sorting or algorithms like merge sort use some extra space. So this is the drawing explanation. Let's see how we can do it in code. Okay, so first let's just sort our array. So nums dot sort, and we want to sort it in ascending order. So inside the callback function, we'll write a minus b. Next, let's declare some of our variables. So min diff, and it will be initially equal to number dot max value. It is the maximum possible value of number can have in JavaScript. Next, a temporary variable result which will be returning as an output. So we'll start a for loop. We'll start from 0, let I equals to 0, and I is less than nums dot length and I plus plus. Next, let's declare our left and right pointer. So let left equals to I plus 1 and right equals to nums dot length minus 1. Next, inside the while loop, we'll run the while loop until left is less than right, and then we'll calculate the temporary sum. So temp sum will be equals to num set I plus num set left plus num set right. Now we need to check if the absolute difference between this, let's call it temp sum. So if the absolute difference between this temp sum and target is less than our previous minimum difference, so minimum difference, this is the case, we'll store in the result the new temporary sum, and we'll also update the minimum difference math.abs to temp minus target. But this is not the case. We have three possible conditions. If temp sum is equal to target, if this is the case, then that means we just return the target. We found the closest sum. Otherwise, we have two more options. If the temporary sum that we calculated is less than the target, and as we have already sorted the array, we need to move the left pointer one step forward. Else, that means if the temporary sum is greater than the target, we need to move the right pointer one step backward. And at the end, after the for loop, we'll just return the result we got. So if we run this, and we got one more error. So in this, instead of just absolute, we will have math dot absolute. Run it again. One more difference. So temp sum minus target. Cool, it passed finally. Let's submit it. Good. Also, we didn't need to write an extra variable mindiff here. We could have just stored this in a result variable and go along with it. That would also have worked. So that was it for this video. Thank you for watching.